What if you could build your own PCBs at home, without chemicals, without soldering, and without waiting weeks for manufacturing? That question led me to invent something new, something I call the 3D printed PCB. Today, I want to show you what it is, why it exists, and how it can change the way we learn and build electronics. I've always loved tinkering with microcontrollers and sensors, but every time I wanted to build a proper project, I ran into the same problems. Ordering PCBs meant waiting 2 or 3 weeks, and that delay completely broke my momentum. Breadboards turned into a confusing mess of wires. Prototype boards were even worse, with overlapping circuits, random shorts, and no real structure. And soldering? One mistake and the module is ruined, not to mention the fumes, the equipment, and the cost. I needed something I could iterate on quickly, without spending money every time I had a new idea. That frustration is what pushed me toward 3D printing, and eventually led me to invent my own 3D printed PCB process. I've always been fascinated by 3D printing. My first 3D printer was one I built myself, but it was the Ender 3 V2 that became my real workhorse, the machine I used to print and refine the early versions of these 3D printed PCBs. At some point, a question started forming in my mind. What if I could combine my electronics knowledge with 3D printing and design a PCB that anyone could make at home? No chemicals, no soldering, just plastic, wires, and creativity. That single idea set off a journey that unfolded over years of trial, error, and constant experimentation. I experimented with everything: different slot shapes, hole sizes, wire paths, plastics, and even alternative connection materials. I even tried conductive pastes and low-temperature solder-like compounds at one point, but they weren't reliable. All of that experimentation taught me exactly what I wanted: something anyone could use, even a child. Something that didn't fall apart, something that didn't require soldering, something that could be reused again and again. And eventually, it worked. A 3D printed PCB is exactly what it sounds like, a circuit board you can print on any 3D printer. Instead of copper traces, it uses 26-gauge wires that slide into printed channels. Instead of soldering, modules plug into printed sockets. Everything stays clean, organized, and reusable. No fumes, no chemicals, no burnt fingers, no wasted components, just plug and play. The beauty of this method is how simple it becomes. You can reuse the same microcontroller, the same sensors, the same OLED over and over again. Nothing is permanently attached. If you make a mistake, you just print a new version. If you want to try a new idea, you reuse the same parts. And because the board is printed in strong plastics like PETG, it's surprisingly tough. It can handle drops, heat, sunlight, and wind. This isn't just a learning tool, it's a real platform for real projects. I've tested these boards in all kinds of conditions, and they hold up incredibly well. Modules stay locked in place, wires don't fall out, and the whole system feels solid in your hands. When I look at what this method can do, I see something much bigger than just a personal project. I see a way for students to learn electronics without fear, a way for makers to build faster and cheaper, a way for communities with limited resources to access technology, a way to reduce electronic waste by reusing components instead of throwing them away, and a way to make prototyping accessible to anyone, anywhere. If you own a 3D printer, you can head over to my website and download a few free STL files to get started. Each design comes with simple wiring diagrams and Arduino code, so you can try the project right away. These are beginner-friendly designs that help you understand how 3D printed PCBs work. And if you ever need something bigger or more complex, I also have advanced designs available on the site, perfect for larger projects or more sensors. 3D printed PCBs started as a personal solution to a personal problem, but today, I believe they can help anyone learn, build, and innovate, without cost barriers, without complexity, and without waste. This is a new way to prototype, a new way to learn, and maybe a new way to bring technology to the people who need it most. Thanks for watching, and if you'd like to follow this journey, feel free to subscribe. Welcome to the future of DIY electronics.